we are going to create a grid. So this is the main form. So the top left is, if you click, it will exit. The second is generate a new model. The button with the folder, it will open your EFDC model and it will save some of your previous projects there. If you want to open any existing without, if you don't know what was the exact location where you saved your model, let's go ahead and create a new model, and then we'll explore other buttons as we move on. So all of the form should look like this. It might have different numbers here, but what we are going to do is change our eastings and northings. So we are specifying the range to what domain you are going to create your model grid. So the easting will leave 0, and the dx we're going to use is 30. So we have a 30 meter wide river channel, and we will have only one cell in the x direction. Just make one. We'll delete whatever is in easting, and we'll let EFDC Explorer find out what should be the number. Now let's go to northing. It's so small. It's 16500. 3 zeros. These numbers came from that original example that I pointed out. We could make it whatever we wanted, but just be consistent there. And our delta y, we want to make it 1550. So from the total channel length, if you divide that channel length by 1550, that would be 40, number 40. So 1540 times 40 is our total channel length. So we'll have 40 cells in y direction, and each cell is 1550 meter wide. So now let's go ahead and hit update. So it will automatically create the values for us. It's just like simple arithmetic, multiplying this and this. However, if you had a polygon, you could set to data and point to a polygon. We're going to use that tomorrow for a 2D example. And if you are going to create the grid only for the particular polygon or particular area, you could specify it here. For this simple example, we're not going to use it. And there is another option. If you want to create expanding grid, means your grid at the original point will be smaller, and then as it moves on, the grid will go on increasing in size. You could do that here if you want, and you could specify the growth factor. I'll let you play with this later. So inside a polygon test option, so this is only used when you specify a polygon. So if a polygon intersects your grid cell, then it will create a grid. Otherwise, if it's outside of a polygon, then it wouldn't include that in your model. So that would be really helpful if you are creating a Cartesian grid and you just want a portion of that grid by selecting a polygon. That will be more clear tomorrow when we are using the real 2D example.
So when you click update, you are supposed to see an update listing.
But so here, one thing you need to remember is you need to delete these fields in order to see the real update values.
Oh.
So out of these three, one of them needs to be blank in order to update. For example, if I delete this and update, it should give me 1. Delete this, it will give me 40. So it does calculation based on the values we have provided here. So now that we have specified our dx and dy, and our dx ranges from 0 to 30 on the east, and on the north it's from 165,000 to 227,000. So that's our model domain. So it has 40 times 1 is 40 grids, right? So channel roughness, will just leave everything the same here. If you want to assign bottom elevation, you can do it, but we will keep it flat here so that we could see how you can modify it later. Okay, let's go ahead and generate. It will say generated 40 active cells in 1/40 grid. Go ahead and click OK. Again, it will give you information like if your I and J orientations are not right, you can go ahead and fix it from EFDC Explorer. But we know that our I and J are right, so we're just going to ignore this information. Go ahead and click OK. Now all of your models should look like this, a straight line here in the middle. So even without going to your view plan, on the main form here on the map, there are 3 fields which will let you view your grid, bathymetry, and depth. Since we haven't specified anything here, we don't have anything to view. If you click on bathymetry, it's all 0 because we have told the program to make it flat. Now let's go ahead and view how it looks on 2D plan. Go ahead and click on view 2D plan and grid and data on the top with this yellow button. So after you click, it should look like this. In order to see the cells clearly now, we're going to increase the cell scale. On the top, there is this triangular button where it says display options. Let's go ahead and click that. After you click that, it will bring to this 2D plan view and 3D view display options. So here are several options where you can change your plot title, model grid, what is the color of the grid you want to make, and the scale modifier. So if you don't change the scale, it will still be it looks like line because both of them try to be aligned at the same scale, and 30 is really small compared to 1550 that we specified. So in order to view it clearly, now let's go ahead and increase our easting factor to 100. And if you don't have your show legend checked, it's on the bottom left. Let's go ahead and click on show legend, and we'll leave everything for now as it is. Click OK. So now you should see your model grid better, and your bottom elevation says 0 to 0 because we haven't assigned anything to it yet, right? Now let's go ahead and view our I and J indices that, as I showed before. In order to view that, go to your viewing options on the top, and there is a drop down menu. Go to cell map. So the brown cell here is selected by default. This is the cell that's being used when EFDC model is run and the results are displayed. So if you want to, let's say if you want to change this cell and you want this cell values to be displayed when the model is running, you can just right click on there, and then at the bottom it says set as show I and J. If you change that, then it will be changed to that particular cell. Now when the model is run, it will show the results for that particular cell. I mean, it's not too important, but it's important to know what's going on. North end, there's nothing much going on here. So if you want to label I and J indices, click on label cells. Then it will show your I and J indices, and if you click on any cell, it will just plot I and J of that particular cell. So if you're curious what might be this cell information, you can find out by this. And this is a nice way to see if your orientation of the grid is correct or not. If you have, especially when you have a complex grid, your grid might be upside down or it might be rotated. So it's a
number ij start from smallest to 3, not 2.
Yeah, first 2 cells are like 0 or 9. So in EFDC model, yeah, if you go to cell.input file, so you have the numbering, it starts from 0 to 9. So 0 means it's land, and 9 is like transition from land to water. So these are all these are not used in the model. So if you have values from 1 to 5, then only it means that there is wet cells, and 1 to 4 it's a triangular cell in different directions. So these are all 5 because it's a rectangular.
It's the two from the boundary, land and
Mm-hmm.
the transition from land to water. So at least 0 and 9.
Mm-hmm. It can be 0, 0, but important thing to realize, it's not the very starting point.
You probably mentioned this before. Just want to double check. The eastern and the northern start with a 1, and the first cell at bottom is 3, 3.
Yeah.
So that's because you just reserve 1 and 2 for other reasons for boundary.
Yeah, let me show you. Let's go ahead and save this model first. I'll show you the input files and then you'll understand what's going on. Let's go ahead and save our model. I had created a 2017 Edmonds folder on my C drive. I'll save it as Hydro 1, not Hydro 1. Okay, maybe I went too fast. In order to save, there is a button on the top where it says Save Project. Then if you want to go folder above, for example, if you want to go to 2017 Edmonds, you have to double click it, otherwise it would go to the current folder wherever it's by default. Then you want to create a new folder. In order to create a new folder, you have to click create new on the bottom. So after you click on create new, it will ask for what is the directory name you want to give, because all the projects file will be saved into one single directory. So whenever we are saying a model, we are referring to a directory where it has all the files together. Let's go ahead and enter name again, Hydro 1. Click OK. So after you click OK, there are several options here. These will be used when you have already a loaded model. I'll go over these options later because it will make sense when you have your model loaded. This is the first time we are saving, so we want to save the model with the full write options. So it will write all the input files, dx, dy, cell.input, and then put it to this directory Hydro 1. Let's go ahead and click OK. So, and at the bottom, after it saves, it says finish saving projects. It's too fast, it already went. Now let's go ahead and view our cell.input files and see what's going on, and we'll find out the reason why it starts from index 3. In order to view that input file, you can go to the input, and there is a drop down next to it, and there is a click on edit cell.input file. It open on this window. So here our cell.input file looks like this, right? So it means there are 2 cells that are 9 that are not active, and it starts from 3rd. 5 is the active cell, that's on the 3rd position. So that's why it's showing 3, 3 on I and J index in your model, in your EFTC Explorer GUI. I mean, you could manually delete 9 on both sides, but it wouldn't matter. Just want you to understand. So if you have 9, another extra column of 9, then it will be adjusted accordingly.
So 9 is the land.
Yeah. So when you have this 5, 5 means a rectangular cell. So if it was a triangle, it would be 1, 2, 3, 4, depending on if it is northwest, northeast, southeast, and southwest. So it depends. So usually we just use 5 or a rectangular grid, unless you have to use a triangular cell. Now let's go back to our view option. Let's go and look into cell indices. I'm not sure why it didn't update here. Just going to change the modifier to 100 so I can view it here. So here in the cell indices, you can see your else. So if you click on show else, each cell will have its own identifier. That's starts from 2 to 41. That's a total of 40. And L of yeah. Then you can also see 3 and I and J on the same cell. In order to zoom, you just right click somewhere and then drag and make a box like structure, and then it will zoom to your area of interest. If you want to zoom out or zoom extend, Control E, it will take back to your original viewing position. These have nothing to do with modeling, but just to understand what cell is assigned to what I and J indices. And there is another option to figure out if you know, let's say I want to find out L of 29 where it is. You can just click Control V as in Victor, and then it will give you option. Enter the L or I and J to view. If you just give one number, let's say 29, we want to see where is 29, right? 29, click OK. Oh, it didn't zoom to the right location. No, let's go to bottom elevation and see if it works there. 29. Not sure what's going on here. Might be a bug. Yeah, we find out a lot of bugs when doing actual training. Control. Hopefully it will work after some settings. Now let's go ahead and assign our boundary conditions before we explore several other features. It's a good idea to keep saving often for several reasons. Your computer might die or whatever, program may crash. So I just like to save what if you change something, I just try to save it so I don't lose it. And if you want to write any comments in your model, go to your description folder where it says project ID. You can write appropriate project ID. I'll write a 1D river. And the run title, if you are running it for multiple times, you run, it's easier to classify or give a different name. Run 1, and you can write here notes, the run 1, and I'll write assign bottom elevation, whatever you want to write, what changes you have made to that particular model. It's a really a good habit to document what changes you made into your model, so when you come back after a month, you know exactly what changed, what there, before you go to diff merge or something to see the input files. Now let's go ahead and assign our bottom elevation. In order to assign a bottom elevation, go to domain on the third tab on the left, and the first tab says grid. It shows how many grid layers are used in our model. We'll go to initial condition and bottom roughness. Here there are three options where we need to specify the input values. On the right where it says legacy, we don't need to worry about it. You don't have to change anything here. These are from original EFDC model. So if you had original EFDC model and you had adjusted bottom valuation by 0.5 or point something, it will display it over there. Right. I mean, you can use it, but it's not required. So let's go ahead and assign our bathymetry. Click on assign. So there are several options here for us. So if we have X, Y, and G data, which usually is the case, you have X coordinate, Y coordinate, and depth, and the bottom elevation. So if you have that, you specify it over here on the data file. That's how you get your X and Y and G. And depending on your data density, if it's really dense, like in each cell you can have 4 or 5 points. Then you can do average data, and if it's in some places there will be no data, right? For this example, since we have only one direction, I'm just going to use a bottom slope in J direction, and our starting elevation is 300. Let's go ahead and put 300, and our slope is minus 0.5 e plus 4. That means 0.5 decimal place is 5. So what happens here is the downstream cell would have bottom elevation of 300, and then based on that slope each cell upstream will have a slightly higher elevation from that. So we can see how the elevation was assigned later in the view plan. So after you have assigned this slope, so this is just a simple example. In real cases you don't do like this. You have to have your real data x, y, and g. Now let's go ahead and click apply. So it says modified 40 cells. That means it has assigned dx bottom elevation to our cells. Now let's go ahead and see. So your bottom elevation should range from 300 to 303.02 something, if you did it right. Okay, now let's go ahead and assign depth to our cells. In order to do that, go ahead and click assign next to depth / work surface elevations. Click assign. Again, if you have data, use x, y, and z, but usually work surface elevations you assign the same values for different cells, yeah, at least under initial condition, because it will adjust in few iterations. For this example, let's go ahead and assign depth instead of bottom elevation and use constant. So we're going to use the same depth everywhere. I'll use the value 1. So I'm going to have a 1 meter depth cell at each location. So inside cell test, again it's for the users who apply the polygon file. If you are not having any polygon file, it doesn't mean anything. So if it's polygon, let me make a graph. If it's our grid, right? So this is our polygon. So if it's inside this polygon, this will be counted. If it's outside this polygon, these won't be counted. So this is like inside polygon test. And inside polygon test, you have two options. Are you looking at the corners or the centroid? So depending on what options you specify, it will assign the values to those cells. Now let's go ahead and click on apply. It says modified 40 cells. Okay, done. Let's go ahead and verify if it did that. Again, go to this yellow button, go to top. Now change your viewing options to water levels. On the depth, it should say 1 everywhere because we assigned depth of 1. However, if you look at work surface elevation, it will be different. It will be just bottom elevation plus 1 at each cell. So good. Let's go ahead and assign bottom elevation in a similar fashion. We're going to use a value of 0.05, I think. Just want to be consistent with what I said before, 0.06. So again, here are different XYZ interpolation options. If you have really big files, it's like specifying how you want to use those data and then assign it more effectively and faster. So since we are going to use constant, 0.06, apply, modify 40 cells, done. Now let's go back to our model. So in order to view your roughness, you have to go to your viewing options and go to fixed parameters, because roughness is not going to change with time. It's only a spatial thing. The first parameter is roughness. If you want to see the cell angles, cell connections, you can see all of those here. So if you go to cell connections and click on north south, if it's bigger than one cell, it will show you the east west on one color and north south on one color. Now that we have assigned our initial conditions for bathymetry, water surface elevation, and bottom roughness, let's go ahead and save our model. Next thing what we are going to do is assign the boundary condition to our model. So in order to assign the boundary condition, we need to bring on the cells or the locations where we want to create a boundary condition. You could just count, and whatever value you think, you can just right click and then assign. Let's go ahead and go to viewing options and go to boundary conditions. So the order I'm doing now, it might be different than the order in the PowerPoint or PDF, but it doesn't matter. There are several ways to do the same thing. I'll assign the locations first, and then I'll import the data. Okay, so let's go ahead and import annotation files which help us to see which cell we want to assign the boundary conditions to. In order to do that, go to display options on the top. It's the same triangular button that we used before. Now we go to annotations. So in the annotations, there are 3 fields there where we can import the data. So the basic difference between first and second is the labels file format. The format is the same, X, Y, and the name of the location, but the function is different. So if you have imported the labels file, you can go to edit labels, and each label can have different fonts, different colors, different shapes. But if you want everything to be consistent, if you change one thing and want every other points to be same, you just use data posting, so it will show all the points with this similar format, color, symbol.
So where are we? So we are.
Yeah, you are on 2D view plan. So in order to go there, click on this display options, and the first tab is general, second is velocity, third is boundary, and fourth is annotations. So we're just importing some information in the EFDC Explorer, so it helps us to assign which cell we are going to assign the boundary to. So now let's go ahead and import our 1D river labels to our model. Click on browse, go to your location where you have all those input files. Now we need to use that, and your location and my location will be different. I have saved it on a different folder. So go to projects and go to 1D river, go to data, and go to 1D river labels. There are 1D river stations and 1D river labels. Click that file and then click open. So after you have specified, it will be populated here on the path of that file. Now let's go ahead and view if that file actually is in the system now. So you can see upstream, east branch, west water, and downstream now on the model. For some reason there is no symbol in my label. Is it the same in your? Now let's go ahead and add the symbol to this. Let's go to the same button and go to 2D and 3D view options, click annotations, and click on edit labels next to labels files here. Edit labels. So if I go over this alone, it would take so much time, so I'm just going quickly. Let's go ahead and select all of the labels at once by clicking one first and then hit your shift and then the last label. So what we are going to change is selected label symbol settings, and then click on all and go to click on edit. So if you go to edit, you will see there is no symbol selected there. So I want to assign a symbol, let's say square crossed. You can change the size, color of your shape, but we're not too interested in changing that. Let's go ahead and click OK after you have done that. So show that now. Click OK. I'll go click OK. Now we can see the actual symbols in our domain. So this means these are the cells where we are going to assign the boundary conditions. While we are doing that, let's go ahead and import our locations where we have the data. Go to the same button, go to annotations. Now we are going to import a data posting file. Click on browse, go to the same location. I think it's better to show you the format here at this point. So the format for these labels are nothing fancy. It's a ASCII file separated by, it can be separated by comma or separated by tab. So the first column is your x coordinate, second is your y coordinate, and the third is your label for that particular location. So this way I have 4 rows for 4 locations. The format for the labels for the measure data is also the same. It's just like you are importing it 2 different ways. So it's X, Y, and label. So having said that, let's go and import that location into our model. Go to projects, 1D river, data. This time I'm going to bring stations. And make sure you click on view label and view symbol, so that way you'll see the locations. Click OK. So now you have your boundary conditions and the locations where you have your data. So it's easier to see what are the actual locations we are interested in. Now let's go ahead and assign our boundary conditions. Let's go ahead and name them. In order to do that, you have to be on boundary conditions again, and you need to click on edit, enable edit. If you don't click it, it will just, if you right click, it will just deactivate those buttons. You have to click on enable edit. Now let's go to the top cell where it said upstream inflow and right click on that cell. So we are going to assign a new boundary condition. So let's go ahead and click on new. So when you click new, it will ask what is the name you want to assign this boundary condition. I'm going to assign upstream. It can be any name which is convenient for you. Click on upstream. So after you have specified the name, EFTC Explorer is asking us what type of boundary you want this to be. We want upfront, this is going to be a discharge boundary, right? So if you have a flow boundary or discharge boundary, you have to input the value 1. If it's a structure boundary, if you have a weir or some kind of orifice or pipe flow, it can be 2. If you have open boundary, that's if you are going to use a water surface elevation, then you are going to use 1 of 3, 4, 5, and 6. Since this is on the east north direction, so if you were to use water surface elevation, you have to specify 6 on this case, because the water will come from this direction. So if you specify 5, then water will come from this direction. So it's important to understand where you want the water to come into your model domain.
EC stands for
Boundary condition. Withdrawal and return. If you have like water coming from this cell and it's being discharged to this cell, then you want to use water withdrawal. So that would happen in those power plant scenarios where water is imported from some upstream cells and hot water is being released, or some pumps. And finally you have this jet plume that you're interested in. If you wanted to create a jet plume boundary, you hit 8, and depending on that number you choose your forms to specify the conditions will change. Now let's go ahead and click 1, write 1, so it will select the flow boundary. Click OK. So after you click OK, then it will give us this form right here where it says our ID is upstream, what number of boundary groups, 1 since we have only one group, and what is the cell associated with that boundary. Now that we have created boundary, first let's go ahead and create all the boundaries, then we'll assign the flows to these boundaries. Okay, now let's go ahead and create a east branch inflow. Point to the cell next to the east branch inflow and right click, click on new. I will write east branch, click OK. It will still be the flow boundary. Click 1 and be done there. So it's the same form, the only thing it's going to change is east boundary ID, rest ID and cell location. So rest are similar unless you specify what flow you are going to use. I'm going to come back again and assign flows to all of these cells at one time. So now we have assigned locations for the boundary condition for 2. Let's go ahead and go to wastewater inflow. I just dragged and zoomed to the area that I was interested in. You can use your mouse wheel up and down to zoom in and out as well. So right click on the wastewater inflow, click new, WWTP, wastewater treatment plant. OK, and still 1. Click OK, click OK. So now we have created 3 flow boundaries. On the downstream, let's go ahead and create on the downstream we are going to use a water surface elevation boundary. We could use the flow, but at least it would be something different, so you would see how the form would look like for the water surface elevation. Let's name it downstream, click OK. And here, if you notice, it's on the southern direction. The cell fishing, it's on the southern direction, so I want a open boundary on the south, so I have to choose 3. So if it was over here on the north, water would come from north, so I would have chosen 6. But it's on the south, so I'm going to choose 3. Let's go ahead and click OK. Okay. So now,
So what did you choose for the first one, for the top one?
I just use flow.
Just use flow.
Yeah, 1.
You use north DC.
No, I was just explaining you could, if you were to use open boundary, you would use north, but we are going to use the flow, so just go ahead and change to flow if you have not done so. So let's go ahead and, if you want to remove your boundary, right click on the cell where you have assigned, and then it says delete cell and delete. So delete cell, there are 2 meanings. If you have multiple cells assigned to a same boundary group, then deleting cell would delete that particular cell from the group. But if you have only one cell, it's the same using this and that. Let's go ahead and delete. You don't have to delete it, I'm just showing here. So now I don't have any boundary. I'll just again assign, if by mistake I chose a different option. That's how you do it. 1, then I'm done. So now that I have assigned the flow locations for all these, let's go ahead and assign the flows to these locations. So there are several ways to assign flows. One way is just right clicking here and go to edit. So when you go to edit, under flow assignment here it says flow table. You need to specify the table. So right now there is nothing is specified, so if you click on drop down, there is none. Now let's go ahead and add the flows. Go ahead and click edit. So this form right here, it's asking how many number of series you want to specify. Since we have 3 flow boundaries, let's go ahead and click 3. So it will automatically create 3 cells here. I want to name my boundary series upstream. The first one will be upstream. We're going to run our model from 200 to 220 days. So the time column would be 200 times space. Since this is a simple example, I'm just editing right in the editor. But if you have a really long data sets, it's best to import it from CSV or Excel or wherever. You can copy and directly paste it in the form. 200. Yeah.
Boundary condition has to be pasted here, not to read from the Excel or text file.
Or you can import it here. Yeah, there are import options, and if you want to import, it would ask if you want to override everything. I think we're going to explore it tomorrow. So the flow value we were going to use was, I'm going to refer this table that I showed you earlier. It was 2.832. So the first column, you have first row, you have 200 space 2.832 means at the 200 time you have that value, and 220 also we're going to have the same value. So it's a constant flow from 200 to 220 days. So if you want to see how your series look like, on the next to view series there is a current, and then go ahead and click OK. It's a straight line because it's a constant flow. That's how you visualize your time series. And if you had multiple layers, yeah, you could choose to sum layers and display everything at once, or if you want to view every layer by layer, if you click OK, it will display the values for each layer.
How do you go to this flow edit?
Okay, here on the edit. Are you on this window yet?
No, yet.
Okay, so go to your boundary conditions tab, right? View plan, and go to your viewing options under boundary conditions. Make sure you check this enable edit and go to this top and right click on that boundary and it will say edit. Okay, so next go to flow assignment here, and below that it says flow table. Let's go ahead and click edit, and you might want to change that to 3 because we are going to insert 3 data sets. 3 and current series is 3. Let me check if my current series of 1 was updated. So upstream you want to use this value from 200 to 220. We're going to assign 2.832 CMS. Next,